So, before we start the workshop, right? Do y'all have all the materials? Download the slides already. Yeah. Or if not, you can scan the QR code
Just scan the QR code.
yeah, to download, or you can. It's up in the folder. Go to buildingblocks.sg/materials under beginners. Yeah, you can find the slides there. Intro to data analytics. Yeah.
Okay. Just leave it on for a little bit more for you guys to scan it. Is it coming? Alright.
That's right.
Okay.
Alright, so hi everyone. So today me and Eugene will be presenting the data analysis and visualization with Python workshop, right? So this workshop is a bit different. This workshop is a bit different from your other workshops because it's gonna be a bit more intensive, alright? So try paying attention
Just
and
stick around.
just like pull through this one and you should be fine. It's a big gap to cover, but I'm sure you'll be able to do it. All right. Yes. If I'm going too fast, all right, me and Eugene are going too fast. Please let us know so that we can.
We'll slow down for you.
Yeah.
We have the time, I think. Right.
All right. So some things about us. All right. I am Danvin. Okay, an IP4 student from TJC. Yes, I like coding and I'm a very friendly person, so very approachable. Yeah.
And I'm Eugene. I'm also a student at TJC, J1 this year. Yeah. Alright. So getting into it, here is a very brief overview of what we'll be covering today. We'll be covering firstly the introduction to our workshop, as well as two packages that you would more likely than not encounter in data analytics, being NumPy and Pandas. And lastly, if you have time, we will cover Matplotlib, but not reflected here, and we will end you off from there. Okay, so the main overarching task for today is to create a cheat sheet that you can sort of use based on the content and functions that we will be covering later. You can fill in this cheat sheet along the way, and a sample cheat sheet will be shown to you in the next slide.
So yeah, this is a cheat sheet by DataCamp, all right, about the basics in Python. So a cheat sheet, essentially what it does is that by looking at a glance, right, you can, when you glance at the cheat sheet, you can essentially know like it summarizes all the things you've learned. Basically, in this case, for the DataCamp like made this cheat sheet of Python basics, right, and then here it states the variables, all right, what are variables, the commonly used libraries, strings, the different data types, and commonly used Python IDEs, which is integrated development environments. Basically, the thing where you code your Python on lah. Yeah.
So
and yes, so you'll be making something like this. Yeah.
Follow this kind of template. If you can't really do it, it's fine. Don't worry too much.
Yes. Yeah.
Okay. So what intro?
Okay. So basically, okay, firstly, what is data analytics? All right, you might be thinking, data analytics is basically the process of examining your data sets in order to find trends, patterns, and draw conclusions about the data that they contain. So for example, if you have like a sales data, you want to know whether your sales is increasing or decreasing, you can just you can use data analytics to analyze the data and essentially draw conclusions on whether your business is doing well or can be improved. All right. And this includes a range of tools and processes, operations used to find trends and solve problems. Solve their problems using this data analysis. Yeah. So this is essentially the nutshell of data analytics. All right. To solve real-world problems by analyzing data. All right. Yes. And data analytics can be split into two main categories. All right. One is data manipulation, and the other one is data visualization. So what is data manipulation? It's basically analyzing and manipulating your data in order to find a trend or a pattern, all right? So that you can, based on that, you can try to solve the real problem. So some packages for this, which Python offers, is NumPy, all right? And Pandas, which we'll be covering in this workshop. And there's also a few, and then after we manipulated data and find the trend, right? Let's say you want to express it in a user-friendly way to consumers or customers or other people, right? Make it look nice. That's where your data visualization comes in. Data visualization is where you will essentially present the data you manipulated and in a form of a graph basically. For example, you want to plot your sales over years, and you can just use line graphs or something like that, so that it's easier to measure how much your you can see it more easily, the change. Yeah. That's essentially it. And some libraries used in Python is to do that is basically Matplotlib and Seaborn. Yes.
Okay. So But if we won't be covering with data visualization today, if we have time, we may cover, but that depends as well. Okay, so let's get into it. Let's imagine a scenario where you want to perform operations over a large list or array. But before we get into that, a quick recap: what is an array or a list in that matter? For that matter, arrays in Python are essentially containers that can store more than one item at a time. In this case, we are storing integers in this array, but you can store many different data types in this array as well. So back to the topic. Will you want to iterate through the entire list yourself? As you saw just now, iteration may be a bit funky for you for now. I'm not really sure what's going on. Or could you perhaps make it easier for yourself? That's where NumPy comes in. So, but before we get started, I'm assuming you have Python installed from the Intro to Python workshop, but if you don't, please install it now. And also a IDE, maybe some Anaconda, Anaconda Spider or anything.
Anyone has pre-built IDEs inside your...
Yeah, you may also have pre-built IDEs as well, depending. Yeah. And afterwards, once you're done that, to install NumPy, the package, you have to run pip install NumPy in the terminal, which my friend here will show you how to do it.
Okay, so for me, I have this IDE called VS Code, which is what it's a commonly used integrated development environment. So what is integrated development environment? It's basically the thing. Okay, it's basically the thing where you code your Python or whatever. All right. So for example, if I want to install a module, so what are modules? Modules are basically packages. For example, NumPy, right? You have a lot of pre-built functions such as your mean function and all that. And all this, we usually, if you, from what you learned, you can just do it by, like let's say I want to find the product of this number, then I can just this number times this number, right? But then what all those experts in computer science, they've created like all these packages like NumPy, pandas, which make it easier to find to conduct all these operations instead of manually having to do that. So it basically makes your life more easier.
Manually having to write the code yourself, you can just use other code.
So for example, if you want to install that module, all right, to use in your script. So all these packages are in your internet, right? So you want to bring them into your script first, into your laptop first.
So
right?
You must make sure you have one connected to the internet.
And you have to type this command in your CMD command prompt, all right? So what is CMD is just you can go to your, if you're using Windows, you can go here, type command prompt, and you can, essentially just type here, right? So for me, I'm gonna use here pip install NumPy, okay? Because that's the module we'll be using today. We enter. It will say I've already installed it basically because
we can show them. We can show them from fresh. So to uninstall, you can just run this, and then
I'm gonna uninstall my NumPy first, right?
Yep. And then afterwards, just run pip install NumPy. So do keep in mind when I said you need to be connected to the internet, is you really need to be connected to the internet. You should run it. You'll be seeing that it's actually using some weird stuff you may not understand. Doesn't matter, just let it install. And done.
You don't need to care about the pip error here. It's just something you don't need to care for now, right? So yes, and it says successfully installed NumPy, alright? And the version of NumPy is in this case 1.24.3, but you don't need to care about that.
Alright, so
that's how you install NumPy, alright?
Alright, getting back to it. Right, so then, now to actually use it in your Python script or your Python notebook, in your cell or wherever you're actually editing, just import the package. Just import NumPy as np, where do note that in this case, np is actually the standard naming convention for NumPy that we use as shorthand, because we don't really want to type out more things, so you just want to type out less things. So now you may wonder, well, what is NumPy? It's essentially an open source Python library that lets you perform mathematical operations over like large arrays or matrices of numbers, and these operations actually have a lot of integration with different packages that you have in Python, like SciPy, for example. That actually makes your life very easy in a sense when you are trying to do any mathematical thing in Python. So then, how do you use NumPy after importing it? So before you can use NumPy and its wide range of functions, you actually will need to initialize a NumPy array. Well, similar to arrays, it's actually once again, it's just a container that can store objects, but in this case, integers. But we are actually converting this array into a NumPy editable object in a sense. So one way to do this, to initialize this NumPy array, will be actually to use numpy.np.array, where the key argument here will be actually the array. So what this does is that it actually converts this specified array that you have into a NumPy array object and returns it, which you can then assign to a variable. Okay, couple of terms came out there. Anyone doesn't understand what the terms are? What term do you not understand?
Any question, just shout out.
Just shout out. Pip install NumPy, is it? Alright, hold on. Let's just go back there. So they can't do torch, dude. You want them to do torch? Okay, so do you have this? Okay, you know what? Might as well do this. Okay. You are on Windows, right? Oh shit, you're on Mac.
Okay, wait, Google Collab, go.
Mac users, I'm sorry, I don't know.
I'm sorry, I'm also wait, open Collab.
Okay, just open Collab. Okay. I don't know. You have to search online for your case. Okay, let's do this. Okay, welcome to Collab. They can screw off. Okay, so essentially it's just if you're running Jupyter Notebook and you want to do this in your Jupyter Notebook, just run bash command in your Jupyter Notebook.
Okay, in Google Collab, right? It's very weird. So you have to add the percentage sign in front of the pip.
Or you use exclamation mark.
Yeah, you can also use exclamation mark when you're installing the library. Alright. Yeah. So does everyone know what's Google Collab, right? You have used it before, right? No? Yes?
Have you ever used Google Collab before, guys? Or have you been using repo.it? Okay, it's fine. Don't worry.
Okay. If not, you can
repo.it, it is essentially mimicking this, right? Just mimicking for example, whatever, I spelled it wrongly, but it's fine. That's repo.it. It's mimicking this, but online. Google Collab is mimicking. Do you have Jupyter?
Yeah. No, I don't.
Oh my god. Okay, bro. What?
I don't.
Okay. Do you have the iPython notebook?
Wait, which one is it?
You found. Let's say
No. Yeah, just
great. Okay. So as you can see, this is a Jupyter notebook, right?
Yeah.
So if you want to, just run this.
Wait, is everyone in Google Collab page? You're not to access Google Collab?
Yeah, because if you are using oh my
Wait,
god,
show them the link of access.
if you want to access Google Collab, just write
Go to your browser.
collab.research.google.com, or you can just search Google Collab.
Yeah, and you press the first link that you get that.
Yeah.
So Google Collab is basically like a repo IT, right? But it's more suited for data science and AI.
Yeah. Okay. Imagine. Okay, you guys have all used Google Docs before, right? It's just Google Docs, but for Python.
For coding, yeah.
Yeah.
That's it. Yeah.
So if you want to run it in your Google Collab cell, okay, just run pip install numpy. If you want to run it in your CMD, then yeah.
Okay, I already downloaded. That's why it says requirement sets.
Yeah, I mean, okay.
Yeah.
Yeah.
Okay, so that's basically how you
Bro, this is not PowerShell, I forgot.
Yeah.
Okay.
So okay.
Any other questions?
Does everyone have Google Collab firstly?
Any other
Open
questions?
up Google
And
Collab.
any other running things that you guys
Sorry?
have played? You can, but I'm not sure if they. I think they have it, but if you want,
wait, I knew if you use Collab lah.
if you want, you can check using piplist.
Okay.
Okay, yeah. Wait, hold on. Just using this as an example.
Import numpy as np. Okay, you're using as np because, for example, when you want to use the functions in that library, right? You don't want to type the entire numpy.mean or numpy.maximum or something like that. You don't want to type the entire thing, right? It's a bit too tedious. So for that, we just use a short form. In this case, it's np, right? So we use like np.mean. You don't need to write the entire numpy.mean or something. Yeah, that's why we use short forms.
So as you guys can see here, if I can, okay, no, I cannot zoom in, but here I initialize a NumPy array and it actually gives me a NumPy array object.
Yes. So the thing inside the NumPy array, the parameter, right? That is a list, which you all know, right? During the intro to Python, they have explained it, right? So what we're doing here is converting that list into a NumPy editable object. Alright. So basically, it's like it's a NumPy object. It's no more a list. So okay, we'll explain more about what's the difference between an array and a list later, lah. Yeah, exactly. Yeah, we'll explain about what's the difference between an array and a list. They are around the same lah, but they have small changes lah, basically.
Yeah,
but
very
so the main difference is that arrays, when you perform functions or mathematical functions over it, right, it's much faster than your normal Python lists. So that's why we're using arrays. Arrays is basically the same as lists.
Okay, so
just think of it like that.
Getting back to this real quick, because we have a lot more stuff. Okay, so other than that, you can also use other one-stop functions. Maybe quite, I mean, not really that useful because most of the time you're going to be using your own. But I guess the more, okay, wait, screw it. But the more, more useful one will probably be NumPy full light because you can actually copy the shape. So let's say I do this. You can actually see that it's just 4 because I mean it's okay. It shouldn't be 1 by 4. Okay, it's fine. No, that's 4 columns. 1 row, 4 columns. Yeah. So as you can see here, the shape here is going to be 1 by 4, as it corresponds to like there's 1 row, but there's like 4 elements in terms of 4 columns. So it's actually how we think about it that way. So the more really key one here is NumPy the full light, where we could possibly just initialize a B array.
Wait, sorry, I think the tag for sales can go around to check
if anything, just ask tag for sale.
Yeah, can go around and check if everyone has a collab and facing difficulty. If participants, if you need help, just raise your hand. Tag for sales will help you. Wait, how many of you are in collab now?
Yeah.
Raise your hands.
How many of you are in collab? How many of you are in?
Okay.
Okay, if you guys are in collab, do you prefer me to type stuff in collab or here, because it's essentially the same thing?
You just use I think it's better.
It's already there.
Okay, so this is basically like your collab lah. Don't worry. This is just
collab is just online of this essentially.
So, I downloaded collab. You can think of it like that.
Yeah. Okay. So as you can see here, this is the first array that we initialized here. 1, 2, 3, 4. There is 1 row and 4 columns. Essentially 4 items in this array. So what full light actually does is that it gives you a NumPy array that follows the shape of the initial array that you specify here, which is 1 by 4, and actually fills it up with the whatever value you specify here in the fill value. So this may be useful in cases where like you are trying to generate labels or something that you can just or you can, I'm not sure but I remember using this a lot, but I can't remember for what. So yeah, just keep that in mind. But we won't be using it. Okay, so let's skip through all this because time. Okay, so that's it. You have a lot of math functions that you can go through. So no, we do this first. So you can do a lot of math functions on arrays. So you can do plus, minus, times, divide, floor division, power, and so on and so forth. So I guess we can kind of show you what's going on here. So let's using the same array. So let's say I do b is equals to a plus 2. What this does is actually it increments every single value in this initial array a by 2. So as you can see here, it saves you the need for iterating through the entire thing. So let's say you wanted to iterate through the entire thing. So
iterate as in go through every element in the array, basically.
So yeah, it's literally a very more tedious process. You have to initialize a new list, then you have to do append number plus 2, so on and so forth. Then you can that's fine. Then you can finally do upper C, then you can get this. So rather than doing that, you can just do one-liner. That's b equals to a plus 2. If you get what I mean here, if you can see what I'm talking about now.
Yeah, so if it's a normal list, you have to go through each element, and then after that, plus 2, plus 2, plus 2, right? But then if it's in an array, you can just automatically just the array's variable plus 2, and then it's just all the elements in the array will just plus 2.
Of course, this works with other things. Multiply works, divide works, so on and so forth. So, any questions so far? Okay, moving on. So, there are also other statistical functions, right? So you can call mean to get the mean of the array, median to get, well, median, STD to get standard deviation of the array. So, in this example here, for example, I have a random list. Okay, maybe I'll just code it out. So, no, I'll just code it out. Okay. So in this case, I have a random list here. Don't really worry about what the numbers are. If you want, you can manually go and calculate the mean of this, but there's no point because it's already here. So you just get the mean of the array. Then similarly, you also get the median of the array when you call median. Then reshaping arrays could also be useful. So let's say you have an array, you have all the things inside already, but you want to perform different operations on it that may not be compatible with the current shape of the array, because in a lot of cases where for packages that integrate NumPy into it, they are very specific about the shape. It's just like your caps lock specific. You need to be very specific about your shape. If not, the operations wouldn't work, or it will just return you an error. So reshaping here, basically the very key argument here is to input here a tuple where it contains the number of rows you want and the number of columns you want. So obviously this one I'll use a code.
Use open paint down to show them just the row and column.
Okay.
Okay, guys. So you might be thinking like the rows and columns and all that. I only learned list or something like that, right? So for this, I will just open up my paint. I'll quickly show you. It's very old software. Yes. Okay. So firstly, right. So what you've learned in Intro to Python is basically your a list, right? This is what, and then all the things in the list, like blah 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 blah. All these things are in the list. All right. This is what you've learned, right? And then what we are teaching now is basically n-dimensional arrays, meaning it doesn't only have one dimension. One dimension, as in right now, is basically just like a list, a normal list with numbers. But then a two-dimensional list will not only have like in your, okay, for example, you think of it in mathematical terms. You have an x-axis here, right? And then you have a y-axis here. So what? Okay, so Eugene is helping me draw, right? So what is a? Okay, yeah. So so a two-dimensional array is basically it has rows and columns like what we showed just now. So in this case, we have one row of 1 and 2, one row of a list 1 and 2, and then we also have another row below the first row, which is 3 and 4. So this is basically what we meant by
n-dimensional
yeah,
array.
you can have as many
multi-dimensional
dimensions as
array,
you want,
yeah.
So if it's three-dimensional,
say,
then you'll have a depth also, like
okay,
a z-axis also. But yeah, you don't need to know that first now.
Going back to this, we know that A has a shape of 1/4 because it's literally right here. So let's say I reshape it to become 2x2 instead. So let's output A. What? Oh right, yeah. Hold on. Technical difficulties. Bracket.
Forgot put in tuple.
What? The hell? Oh my! What the? Okay, I give up to it. Help. What the? Wait. Let me check.
You're putting a shape, right?
Yeah.
Yeah.
That's very funny. Okay.
It's fine.
It's fine. Just wait. Yeah, it is wasting time a bit, but it's fine. Yeah, there we go. So, as you can see here, yes, two things here. It's like up and down. There's like number of rows is like 2 now. Yeah, there's actually 2 columns also.
It's no longer in one dimensional. It's not straight anymore.
It's no longer like this, but rather like more like a
there's like
two dimensions to it lah.
Yeah.
Essentially.
So it's no longer the x-axis only. It's also x plus your y-axis now.
Yeah.
And then usually for like when you learn volume, there's like 3. There's
yeah.
one
So you
set,
can also do that lah, but
yeah.
I don't think we want to do it right now. So okay, moving on. Oh my.
Okay.
Spoiler. Okay, but concatenating will also be quite useful. So to concatenate NumPy arrays, you actually can call hstack, which is stacking. In a sense, stacking 2 arrays horizontally. sort of combining two arrays this way. And to make it look nice, I mean, you don't want it to have a different height, so you just want to make sure that the number of rows or the height is the same. So a bit more clear. If I were to do an example, it would probably be a bit more clear. So let's say I have an array that is 1 by 2 and 3 by 4, just like earlier. Then I have another array B as maybe, since it needs 2, right? So I'll just do 1 and 2. So when I assign C to be the B, when I actually do what? Oh my god. Okay, hold on. One position argument. Oh right, yeah, this needs to be in the tuple or something. Yeah, so as you can see here, you have the initial array that is 1, 2, 3, 4, but you are actually stacking it horizontally, just adding it on horizontally to the new array. So 1 and 2 is added on horizontally here. So as you can see, that's what it does. And similarly, VStack, you have to call VStack. Now in this case, you want to actually make sure that the number of columns are the same. So yeah, I'll just do this, and then I can do even more rows if I want to. For example, if I do this, so maybe it'll be clearer if I show it to you like this. So it's supposed to look like this. A and B are supposed to look like this individually, but when I do VStack, it just added vertically upwards, just stuck up there in a sense. So you're just adding this on below the initial array that you have. So yeah, this kind of summarizes it, just like what I showed earlier lah. So okay, so nextly you can actually compute more statistical things that if you need to, so that you don't need to use your brain to go and calculate it. You can call percentile, where you have to specify the array as well as the percentile that you want to compute out, or the list of percentiles you want to compute out. But do keep in mind that it must be 0 to 100. So going back to this, let's say I have now I re-specify the array as like 1, 2, 3, and 4. Then I just do this and 50th percentile, for example. Then it will actually be 2.5 because 50th percentile is in 2.5. So if I do 70, it will be 3, and then if I do 100 percentile, it will be 4. So that's what it does. Then quantile is also similar, but you're actually just computing the quantile instead. And quantile range must be between 0 and 1. So let's say I do quantile with the quantile set here to be 70. Actually, it wouldn't work because it must be in the range of 0 and 1. So what you do, instead of using 70, is actually use 0.7, and you now compute the 70th quantile. Or maybe let's say do 0.6, actually compute the 60th quantile. So next, matrix multiplication. This is actually what many machine learning models are based on. When we do backward and forward propagation, we actually do all of this matrix multiplication. So this is quite useful. I mean, maths also, if you want to have help for your homework, you can also use this. So in this scenario here, I sort of create two matrices A and B, 1, 2, 3, 4. So that's 1, 2, and 3 and 4, 5, 6, 7, and 8. So then when I do matrix multiplication, it will actually just return me the self-intuitive. I mean, yeah. Then for more statistical stuff, if you want to, you can sort of create a linear regression, a semi-linear regression by using core coef. Basically, what it does is computes a correlation coefficient, which is actually a measure of strength of a linear relationship between 2 points. So let's say that you have a strong positive relationship, aka one goes up, the other also goes up, then it will be 1. But then if it's negative, actually one goes up, the other will go down. So yeah. So that's something. There are also more functions, but very time constrained, so we won't cover them here. So if you're interested, you can follow the link to find out more.
Okay. Okay, I'll start teaching. Okay, yeah. Test. Okay. So I'm gonna start teaching about a step further than NumPy. Okay, a bit deeper into uh, uh, data analytics. Okay, which is using the pandas library. All right. So for those who are still unsure about NumPy, okay, you can ask the tech fossils who are going around.
Oh, you can
okay?
ask me. I'm gonna
Yeah, Eugene is also going around. You can ask him too. Then he can help you explain what NumPy is for those who didn't get it, right? Yeah, sorry, we were going a bit too fast because of time constraints, alright? But feel free after the workshop, there's lunch, right? You can approach me or Eugene, and yeah, we'll be more than happy to explain to you how NumPy pandas work, right? So for now, I'll just go to pandas first, okay? So let's imagine another scenario, okay? Your boss asks you to get the data of a sales where the sales volume was very large, along with a few other stats. Pretty simple, yeah? You can just use Excel. But the catch is the dataset look like this. You have so many columns, so many rows, like oh my gosh, so messy. Yes. But there's also another catch. The dataset was so large that it could not even be loaded into Excel because Excel has a limit of 1,000,000 rows. And it will be too slow to identify columns of like a large datasets with or perform operations over columns of large datasets in Excel. It's gonna take like maybe 4 minutes, something, a lot basically, a lot of time. So how else can we do it? Excel is the only thing I know which you can use to do like data analysis, right? Which a lot of people used before, right? So you can't just sit there and tell your boss, oh my god, boss, I really cannot do this. It's not possible. Then you get fired. That's not what you want, right? Are you going to try your best to collate all the information within a time given? No, unless you're an Excel whiz. Yeah, no. Yeah, so that's where pandas comes in. Okay, not this pandas, although it looks very cute, right? But not these pandas, but the Python module library pandas, right? Alright, so what is pandas? Okay, pandas is basically an open source library for data analysis in Python. So as mentioned before, NumPy arrays is basic. So this pandas module or library is built on NumPy. Okay, and essentially what this does is that it helps you do perform operations over a dataset more easily, all right? Or yes, find patterns and trends like I mentioned before. That's the purpose of data analysis, right? Yes. So it provides fast, flexible, and expressive data structures, okay, designed to make working with your structured data such as your datasets more easy, all right? And it also allows you to perform a variety of operations such as finding your maximum or the mean of certain columns or a set of data. For example, you have sales of like from a few years of sales, right? And you want to find the max of those sales, which year you got the highest profit. Then you can just call np dot. You find the maximum of that column, right? The maximum data of the entire column to find like the highest highest like value lah, basically, which year had the most number of sales. So that's basically pandas. Pandas is like it's basically your Excel tables, right? But in Python, yeah. So yeah, basically mimics your Excel. So why use pandas? I don't want to code, right? Why do I have to use pandas? I can use Excel for easy access. But here's the catch. The benefits of pandas over Excel is that one, it is very fast. Okay, it's much more efficient than your Excel, right? It is also very flexible, okay, because it can be integrated with other tools such as your matplotlib. Matplotlib, like I mentioned before, for those who are listening, it's basically after you manipulated your data, find your patterns and trends, you want to express them in a way that others can like also, once they see, they can identify the change very easily, right? And for that, you can plot it in a graph format or anything. For example, going back to my example of sales, let's say I want to show that my sales is increasing in this company over the years. And then you can use this matplotlib to like, after you find the data trend, right, you plot it as a graph. And then and then when a person looks at it, it can automatically identify from a first glance, oh my god, the line is increasing. It's my sales is increasing. Good, profits. Yes, yeah. So this is one application of pandas, yeah. And it's also very cost efficient, as mentioned before, because Excel you have to pay, right? And it's not cheap, okay, especially for enterprises. Enterprises, like for example, all these big companies, a lot of employees, right? It's gonna cost like, I don't know, a couple thousands or something for getting Excel for all of them, right? And Pandas is an open source Python package, thus it is very freely available for use. Yeah, so anyone can use this as long as you download the package and you have Python installed. Yes, with Python interpreter. Yeah. But wait, hold on. Before we get started, do you have Pandas installed? Or if not, how do you use it, right? So firstly, like Eugene mentioned earlier, you have to go to your terminal and type pip install pandas. But for those who are using Google Colab, right, you don't have to worry, okay? Because pandas is already pre-built into the Colab. It's already installed already, so you don't need to enter that lah, basically. Yeah, and you just need to in your first cell. Okay, when I went around, I noticed that a lot of people were just typing in that same cell lah. But then for importing packages, right, it usually has to be in a separate cell. So in the first cell, your cell as in like when you press the plus code, then you get that box, right, where you can type your code in. That's what I mean by cell. Yeah. So first, to import the library, what you can do is import pandas as PD. And as mentioned before, PD is the standard naming convention for pandas, right? Because you don't want to type out because if you want to access all these functions in this library or anything, right, you need to call you have to type pandas dot the whatever function you're calling. But that's very tedious. You don't want to type like 5 letters. But it's 6. 6. Oh shit. Okay. Yeah. So you don't want to type the 6 letters. You just type 2. It's much more efficient and faster, right? Yeah. So that's why we have PD. Yes. And you can just type PD dot let's say whatever function you want to call, right? I'll explain more about what functions pandas offers into it. Okay. So more about pandas, alright. Let's go to the functions. Okay. So pandas has many various functions for you to use. Yeah. And for example, let's say you have a CSV file in your File Explorer. All right. So what's a CSV file? Okay. CSV file is basically comma separated value files. Files that contain your data, like your structured data. For example, it's basically Excel files, but stored in a text format, just separated by commas basically. Yeah. So if you want to read these CSV files, what you can do is Pandas has a pre-built function for you to read these files, right? So one way to do this is using pd.read underscore CSV with 2 brackets, all right? And this lets you read the CSV files from your and then convert it into a data frame, which is like a Pandas object. Pandas similar to how lists and all are like Python objects, right? Like the pre-built objects, the ones which are default in there. And then you also have NumPy, like arrays. They are also like NumPy's objects, NumPy's data types, right? And then in this case, Pandas data types are like data frames, which is what you describe your tables basically. Yeah. All right. So yes, so coming back to this, it helps you read the CSV files and convert it into a data frame object. Okay. After that, you can call df.head. So what this does is basically, let's say you want to print some rows of the data set, but you don't want to print everything. I just want to check how many columns there are. I don't want to go too deep into it, right? And for that, you can type df.head function, and by default, if you don't specify anything inside as a parameter, meaning inside the brackets, you can then by right default is 5 rows lah. So this and your output will basically be the first 5 rows of your data frame. All right. I'll show you the example of this in the next slide. And yes, you also have df.describe, which so this function returns the mean, standard deviation, your count, and a fine number summary of the data set. This one I'll elaborate more in the next 2 slides or so. Yeah. So okay. So creating data frames firstly, right? We need to know how to create our data frame, right? So as mentioned before, there is the pd.read CSV function. So this method can be used when you already have a pre-existing data frame stored as a CSV file or an Excel file. Okay. So so how you can create a data frame object is that you assign a variable called tf, okay, equals the function pd.read CSV, and you specify the file path of the CSV file, okay, inside the bracket here as a string. Okay, it must be in a string format or I'll show you an error. So what's a file path? Wait, do y'all know what's a file path, right? It's basically the path in which you can just go to your File Explorer, okay, and then right click on the CSV file and press copy path, paste it in here, and it should work, alright? And in Google Colab, Google Colab is online, right? So you may not be able to detect the files stored locally in your computer. So for that, you don't need to worry about it because in our data set, like in our materials data, in our Go Collab, we already have uploaded the files for you in your Go Collab, so you don't need to worry about that, alright? But yes, if you're interested in this, you can just like ask me or Eugene after this, yeah. So okay, let's say you don't have a CSV file. Like, who uses CSV? Bro? All of us use Excel. Then you can. Pandas also has a read Excel function which reads Excel files, okay, and converts it into a data frame object. All right. Yes. And yeah. Okay. So this is another method of creating data frames, which is basically creating a data frame from scratch without any existing data frame. So you can do this by using the dictionary. You can convert a dictionary into a data frame basically, right? So for this, let's say we have a dictionary data equals to the key name. Okay, you all know how dictionaries work, right? Okay, what are two things in a dictionary? Two things in a dictionary, important things. One is the key, another one is the value, right? Correct? Yes, sir, guys. You're there? Yes, yeah. So yeah. So for example, in this case, our key is basically the name, and our value is basically a list of names. For example, we have Tom, Joseph, Chris, and John in this case. And our key and then comma, we also have another key which is age, which corresponds to the corresponding ages of the people. Basically, Tom is 20 years old, Joseph is 21, and so on and so forth lah. All right, and then when we call df equals to okay, you assign df as a variable and equals to pd.dataframe, all right, and then you pass in the dictionary variable as the parameter, right? So what this does is that it will basically like convert the dictionary into a data frame object, right? pd.dataframe, it's a method, yeah, and you can see here basically how it looks like. Oh shit. Yeah, you can. This is how it will look like. Name, under the name column, you have your Tom, Joseph, Chris, and John, whichever you specify in the list here. And under age, you will have 20, 21, 19, 20. Yeah, the corresponding ages here, right? Yeah, so this is a simple way of making data frames. So for you can just experiment with different values, okay? Maybe, I think this is a much more easier way of you practicing. You can just maybe put whatever key you want and then the corresponding names. Oh, one more important thing. The number of items in the list here, right, must be the same as the number of items in here, or else it doesn't make sense, right? You have 5 age, but you only have 4 names. It doesn't make sense. So then Python will throw you an error, basically, yeah. Yes, and then after you created your data frame, right, now there is accessing columns of the data frame, okay? So what do I mean by accessing? I want to just see the specific column. I don't care about the rest of the data set, right? For example, I just want to see my sales. I don't want to see what name, who bought it, or whatever, right? So for that, we can access the columns of the data frame by calling df bracket and then your column name as a string inside the square brackets. So this returns you the row of data under that column. For example, in here, I wrote pd.date. So I put df bracket status, alright, dot heat. So what this does is that it prints the status column of your data frame, okay, or data set, and as I mentioned before, if you put .heat, right, call .heat on this thing, it will only print the first by default, the first 5 rows, just to give you a summary on how it looks like And yeah, so like here, when I call this, right, I want to print the first 5 rows of your status column, and this is what I get. Okay. Oh, by the way, guys, columns are horizontal, rows are vertical. If you are still confused, yes, yeah. So yes, and then here you can see your first 5 rows, which is shipped, which is good. Yes. Okay. Now remember I was mentioning something about .describe function. So let me describe to you what describe function does. Okay. So the df.column.describe function basically gives a number of rows of more info about the data of that specific column. So for example, if I call df.status.describe, okay. Oh, in this case, you do not have to specify your you don't have to specify your column as a string. You can just put df.status, alright, .describe. And what this does, it basically gives you the number of data in that column. For example, in this case, my data set I have 2,823, and the number of unique values in that column, such as unique values as in those values are different from the majority. or if I have my majority shipped, right, and then there are 6 values like maybe cancelled or something else lah. Basically, yeah, they are different from the rest. And then you also have and then the top value, the most frequent value is shipped, right? And the frequency of the top value, the most frequent value is 2617. So you get useful insights such as these. Okay, it might not seem very useful to you at first, but when you work on certain projects, all right, you can easily extract all these information from the data set. Yes, and yeah, it also give you what type of an object it is. Data type. Okay, so similar to the describe function, you also have value count function. So what this does is that it zooms in more into the unique value part. So in this case, it zooms in into how many of those unique values are and like what unique values you have lah, basically. So here, when you call df.status under the status column .value count, it will count the number of different values you have. For example, here I have 2617 shipped. All right, and it also elaborate on the unique values. So my unique values are cancelled, which I have 60 cancelled, and then I 47 resolved, 44 on hold, 41 in process, and 14 in disputed. Yes, it gives you more insights on what kind of unique values you have. All right, yeah. Okay, so now that we have learned how to access the column, right, let's go into more about filtering or locating different columns. All right, filtering and locating, as in you just filter by a Boolean value. So you all know what's Boolean, right? True or false? Yes. Yeah. So when a condition is met, it will be written as true, and when a condition is not met, it will be written as false. Right? Based on that, if it's true, it will then output the value. If it's false, it will then not output the value. All right? Yeah. So df.loc, and then you bracket, put in the label. So what loc is basically, stands for locate, right? So df.locate this label, right? This column, okay? And if that column is located, it will return as true, which will then output that column. So this is used to locate the rows of data under that specific label, and it also works with Boolean arrays. Okay, so we can also use integer locate. So what's integer locate? You know how in your graphs you have x and y coordinates, right? So similarly to a data set, all right, in a matrix, basically, if you have like, okay, you're finding the x and y coordinate of this particular thing. For example, I want to find the sixth column. Then what you do is your x coordinate is basically 6. So then that will print all the data, all right, under the 6th column. So this is one way of using integer locate to kind of calculate which column you want it to output basically. Yeah. So yes, and in this case, okay, let's go back to locate. All right. In this case, when I call df.locate 0, it will, okay. You might be thinking, is it an integer locate? Because it's a 0, it's not like a string, or it's not a text. Then isn't it integer locate? No. But the thing is, the catch is here. 0 in this case is like a label. So what this does is that it will, when you call df.locate 0, okay, it will locate the column, the row with the label 0. In this case, this column basically, okay, this row basically satisfy that condition, because it's 0 lah, the row 0. So then it will output this entire row, and yes, you will then get your statistics on your information on this row 0. Yeah. So there's also more function, like mentioned before. You can also use it with Boolean values. Yeah. So if I call df.locate df column state. Okay. So what this does? Let me break this code down for you from the second, right? So df status equals cancel. So what this does is that it checks whether any data or any data under the status column, all right, is cancelled. And if so, it will return as true, and it will also print or output. You locate all those rows which are true and output them. All right. So yeah, that's what you get here. All these rows are basically cancelled, but they are not by order, as you can see here. But it just prints all those rows which are cancelled. Basically, status is cancelled. Very bad sales. Yes. Yeah. So there's an alternative method to this. All right. It's called .query. All right. Those who have done SQL before. Anyone? SQL? SQL? No. Oh, okay. There's a few. Okay. So those who have done SQL before, all right, you might find it a bit familiar. So what's a query is that query is basically like a string. So when you're searching for a you're basically searching for something. Sorry, not like string. You're basically searching for something in that data set. So in this case, if I call df.query, right, and then I insert the condition as a string, it must be in a string format, right? Then you can filter all these all the columns or rows based on that specific filter. Okay, it's basically like your Excel applying filters on it. Yeah. And in this case, I call df.query, all right, where my price each column, okay, of this data set, all right, is more than 90. So what this does is that it will give all the rows, all right, in which your price of the price each is more than 90. So $90 in this case, yeah. So you can see here, all right, all these rows have their price each is basically more than $90, right? Even peaking to 100, yeah. So yes, okay. Now that we've learned how to filter columns and all that, right? Let's talk about aggregating functions, all right? So what are functions? Basically your mean, your max, all these are the ones you've learned in NumPy lah, standard deviation and all that. So in order to so one good thing about pandas is that it allows you to carry functions. It allows you to perform functions over a data frame. So in this case, when I aggregate, and the functions you want to aggregate over must be in a list format, right? In a list. You must take note of all these things. What kind of a data type it should be basically as a parameter in the function. Right? Parameter is basically the things you put inside the brackets, okay, of the function. So in this case, if I put df.aggregate, okay, I want to aggregate this list of functions over this data frame. It will then output all these, the output of the mean or whatever you want to find lah. So in this case, the list of functions can be your sum, mean, standard deviation, or anything. Yeah, any user-defined functions also can. Yeah. So okay, yes. In this case, if I call df dot I want to find the mean of both my price each and sales. So in this case, I put it as a list, alright. Your price each and sales must be in a list format. Okay. And then I want to aggregate mean, okay, over these two columns. Okay, so what I want to do is that I want to find the mean of both these columns. And here you can get in this case your price each is basically your price each is basically 83 point. Okay, in this case your mean of your price each lah. So my price each, the mean of this sales is basically the price each is basically 83.73 SF. Yeah, and the sales is you get the mean of that also like here. Yeah. So this is one way of finding the mean of a column or of a row. Sorry, many data in a one column lah basically. Yeah. Okay, so let's go into data cleaning. This might be a bit more easier for you to understand, I think, right? Assume. So in the real world, right, a lot of us won't get very pure, clean data sets. It's usually very messed up. You have a lot of missing values, so it's hard for us to perform operations over every element in the data frame. So it will return an error lah. So I'm gonna teach you how to clean this data set, all right? Or data sets which are a bit messy. Yeah. Okay, so to do this you can call df.isNow. So you need to first find how many of these missing values, okay, you have in each of the column. So when you call df.isNow, right, .sum, what you can do here is that it will show you how many missing values there are in certain columns. Because so some of these data in all the columns might not be filled, right? You have an empty column, empty cell or data cell, yeah. So that will cause an error because you can't carry your operation or find the mean of an empty thing, right? It doesn't make sense. Yeah. So for that, what we can do is df.isNow.sum, and this will basically find output all the columns here and how many missing values there are. And in this case, we have 0 all the way to address line 2 because some people might have 2 houses or something lah. So we have 2,521. Yeah. And then your state also, you have like 1,486. All these are missing values in that specific column. And yeah, so this means that we cannot carry out operations in this data set or these columns because you can't, like I mentioned before, you can't find the mean of an empty thing or max of an empty thing. Doesn't make sense, yeah. So okay, let's say now we're gonna look at how to clean the reduce all these missing values. Okay, to clean the NA data, NA is like not existent or something like that lah. So okay, to clean all these missing values, all right, we can use df.drop NA, all right, when you put a subset equals to whichever columns you want to apply you want to remove the NA on, all right. In this case, I want to remove it on postcode, okay, postal code, yeah. And my axis is equals to 0. So what is this axis equals to 0? So axis equals to 0 is basically like, okay, axis equals to 0 means that your iteration of basically every element it goes through will be vertical instead of horizontal. So if your axis equals to 1, right, it's gonna go cleaning like this instead of like this. So it's not your column, but it's gonna start cleaning a row, which doesn't make sense because you wanna clean all those NA values in that specific column, right? Yeah, and in place equals to true basically means that it won't duplicate your data set then give you the NA the clean values. It will just apply it on the data set you're working on itself. Alright? Yeah. Yeah. Okay. Now it's the easy part, right? Now that you filtered, manipulated data, all that, right? Now you want to let's say save it, okay? Save it as an Excel file in this case, right? To do this, you can simply call df.toExcel, okay? And then you can pass in. So these are the parameters that you can pass in lah. Some are optional, some are like must. For file path is a must, okay? So when you call df.toExcel and you specify the file path in which you want the dataset, the key of, let's say after you find a specific trend now, you want to save that dataset in your computer, right? In an Excel file. So what you can do is that you can go df.toExcel and then you pass in your file path as whichever folder that you want to save it in, the sheet number or like, and then your missing data representation. So let's say you didn't clean the NaN values, right? And then how you want it to be represented when it's saved. You just wanted to let it be NaN rows, NaN meaning there's nothing in that cell or data cell, or you want to replace it with 0, which is what we do for sales in this case. Yeah. Yes, usually in sales, I think they do that, if I'm not wrong. Yeah. Yes, and then this will let you save the data frame in your laptop. Yeah. Okay, so there's a lot more functions available. So what I've got now is basically trying to summarize all of NumPy and Pandas, which is probably like just 10% of them. But there are a lot more functions available, right? Don't be frightened or surprised if there's like a lot of this because you're just you're beginner track, right? So from intro to Python that you start learning Pandas and NumPy, that's actually a big leap, right? So it's normal if you're confused. But if you want to know, if you have any questions or anything, you can just ask Tech for Sales or me and Eugene, alright? During lunch or now also can while you're doing your activities, alright? Yeah. And yes, and if you're more interested in all these functions, you can go to you can scan this QR code, go to the actual Pandas official Pandas documentation, or you can also type this link here. Alright? Yeah. Okay, so time for some practice. Okay, now that you learned how to do all these operations over this function, all these arrays and data sets, right? Let's go into okay, so you can go into the first notebook, right? Labeled as manipulating data part 1. Okay, for this, wait, let me bring you back to the materials page. Okay. Yeah, this one. Yeah, this one. So you can type this this URL and go to the notebooks and datasets folder. Yeah, Google Drive. And then there you can find a few Google Colabs in which you can practice. Alright. Yeah, you just experiment with it. Okay. Most of the code is already written that way, so it's just mainly for like practicing and learning how getting hands-on with it basically. Yeah. So if any questions, I'll just be walking around. You can just ask me. Yeah. Oh, by the way, when you go into the collab, right, you have to make a copy of this Google Drive, alright, and create a shortcut in your Google Drive. If you're not sure, okay, so I think I'll just show you how to do it now. Okay, so shoot. Okay, open your okay. Yeah. Okay, so let's say we have the notebooks and this folder. Visualize. Okay, manipulating data part 1. Okay, these two is a bit extra, right? So you do not have to do it now, but if you're interested, you can go do it. Yeah, I recommend this first. Okay, get your basics right first, then you can go a bit into advanced sklearn or what's the other one? Oh yes, Matplotlib. Oh, Matplotlib is the data visualization. I don't think we'll be covering this because I think y'all need a break, right? Because you need to like, yeah, y'all need to understand the basics first before you can go into that. But I'm sure you'll be able to do it, right? Yeah.
Yeah, done. People
Yeah.
are sleeping, bro.
Sorry?
People are sleeping.
Me?
Yeah, no, people are.
Oh yeah. I don't want to bore you all, so you can get hands on first, alright? Yeah, I think the best way to learn is not by lectures like what I did right now, but is to also get hands on, alright? Try out the functions. Yeah, experiment with what they do.
Yeah, try out yourself. Don't be related to any like the external you're given. Just
You gotta do
do your own thing if you need to as well.
facts.
Essentially.
Okay, guys, yeah. So there are many practices for you, like such as converting your array into a NumPy array, right? Array as in a list into a NumPy array. Okay. Yeah. So all these you can just refer to the slides, right, and try it on your own. Okay. The answers are already on the slides. Basically, you can just like, but the purpose of this is just for you to experiment and yeah. Yes. Okay. Does everyone have the link? Sorry. Yeah. For the datasets, sorry, the Jupyter Go collapse.
You named that.
Sorry?
You got that.
Yeah.
That tiny URL is still active.
Yeah.
God damn. Does anyone not have access to that?
Raise your hands if you don't. Raise hands, yes.
Yes. Hold on.
Yes? Don't have access?
David,
Okay.
go have a create a shortcut.
Let's go.
Or you can show them how
Oh,
to create a
wait.
shortcut. Okay. David,
Wait, do you mean? Yeah?
show them how to create a shortcut.
Yeah. Wait, do you mean edit? Are you gonna edit it? What's your name? Sorry. Her name is? Sorry, wait, do you mean you can't edit it or?
No, David, they are on cannot save changes.
Oh, right, okay.
So it's fine. You need to show them how to
Okay, so
create a
you can make a
shortcut.
copy to drive first, alright? For example,
David, it's fine. You can run output, but you need to show them how to create a shortcut.
shortcut. Oh, okay.
Yeah,
Okay.
you need to show them how to create the
Exactly,
shortcut for the
yeah.
folder.
Okay, so
Just go back into Google Drive.
yeah, so this, then I will copy in drive, if I'm not wrong. Okay, I copy, oh shit, okay, you know what, let's do this.
Whoa.
Okay, wait,
Bad word.
okay, wait, so,
How dare you?
okay, drive, okay, so you press okay, drive. Why is it loading? Okay, then, you can press add shortcut to drive, alright? And then,
David,
once
David, press the folder and the processing data in Python folder.
sorry?
They need the entire folder to
Oh, they want to enter, oh
Entire-
bro, okay.
chat.
Okay, this thing
Yeah.
Okay, guys, okay, sorry.
And no, you need to right click the thing on top beside the share. Beside the share.
Which one, this?
Beside, yeah. Right.
Oh, entire processing data.
Yes.
Oh, bro, okay. Okay, guys, change your plans. So you need to, okay, after you access the folder, right, go here, right, the processing data with Python folder. You have to press this drop down button, and or you can right click here also, and then press add shortcut to drive. So once you've done that, I will ask you where just like, okay, let's say I put Colab notebooks, okay, press add, and it will add a shortcut. Alright, so after it's done, you can just enjoy here, editing, running it, just have fun, and refer to the notebooks, so your slides here on how to convert arrays, all these, and then just fill up these questions. Converting list array, you can just just have fun, guys. Basically just experiment and I think me and Eugene will just walk around in case you need help. Raise hands if you need help.